So one of the biggest mistakes I see on this is to do something like this. You can see why somebody might believe this to be true. But can you imagine if you actually did this? Do you see all the extra terms you'll get that aren't supposed to be there? But real quick, just to show you, this is interesting. If you multiply these together, you'll get x squared plus 5 plus 5 plus 10x plus 25. Now, I just want to leave that there for a second. This is obviously not the answer because look at all the extra shit you'll get. Nothing's going to cancel there, right? And so let me take this even one step further. Then somebody might get kind of smart and say, well, maybe these are negative. Right? And then you'll get, but then all that's going to change really is that. And you still get 5x squared minus 10x squared. Those don't cancel. So you're not getting the right cancellation happening. So it never can be this easy. It's got to be a little freaky to make sure that things cancel the way they're supposed to. But let me leave this here for a second because this is a little dude, big dude thing, isn't it? It's interesting. It's close to what's right. In fact, you guys, if you've done it, you should see how close it got. So this is, of course, XXX. This one, of course, we know is 555. So the big dude, little dude, we put
X plus 5.
Good. And the big dude gets
X squared. And then plus 25.
And then this has got to be
Negative
minus.
5x.
Notice how the middle term in the big dude will always be half of what it would be to be able to factor. Because you can factor this, bam. You can't factor the big dude because the middle guy is always half of that. So there is like a method there that I was kind of toying with, but then I decided, no. But you guys see how there's kind of a method here that you can actually use to get that. You do this and then you just cut that in half, but that's a little too vague, I think, as a teaching tool, right? Just to show you that's kind of interesting. And just to remind you guys, if I let x be some number, this will be a number and this will be one way to factor, right? Always. So you can always check it that way too. What about this dude? First piece will be 2p, 2p, 2p. 1 times 1 times 1. Yeah, that's the alternate universe Hamlet, something like that. Well, it is nobler to wait until there's a bathroom. No? Okay.
2p.
Yeah, one of these 2p's go there.
And then
Minus one of these 1's go there. 1 is fantastic. Bring it up as many times as you want to. Then this has to go here.
4p2.
4p squared, I like it. And then that, of course, has to go here. 1. Always positive. What's the middle term in this case going to be?
2.
Positive 2p.
Oh. Yeah.
Sweet. So this is one of those times I would go against. Normally my advice right before a test is don't look at anything at least 10 minutes before a test. So all you're going to do is freak yourself out. You're going to be like, I forgot. It's not taking this. This is something that I might do a couple of right before a test just so I've got the process in my brain. It's just students have a lot of trouble remembering the process. So I try to make connections with why it makes 1/3 of it, 2/3 of it. So it makes a whole. Yay. One piece, the other 2 pieces makes a whole. Yay. And then this is the weird guy, but hopefully I've explained that one enough. This one, how does this work? This will be 3m, 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 n.
So 3m.
Yeah, 1 3m
And then
minus 1n,
and 9m.
9m squared,
Squared.
n squared. This is going to be plus
3mn.
3mn. Okay. All right, so last thing for today. It's coming up right now. Wasn't that all? What is this is about to die? Don't worry, we'll move you to that chair for you. Yes?
Why did you put for second one negative 1?
Oh, the little dude is always going to have the same sign. It's always going to be the same sign.
Yeah, but why didn't you multiply it? Because it's negative 1.
Oh, why did I put a negative 1 here?
Why didn't you?
So the way I do these is if if that's a minus, I know that's going to be a minus, and that's a plus, and then I forget about that sign. It's not. I don't look at it as a -1. I look at it as AP cubed minus 1. Now, I was just talking to somebody else. You could do this, and then that -1 goes there, and then -1 times -1 is +1, and that's got some advantages because that explains why that one's always positive. But that leads to weirdness. So it brings in negatives when you really don't have to. It's got some nice things to it, but I decided not to teach it that way. But some of you guys might be able to see. You could bring that in like it's a -1 there and break up -1 as -1 times -1 times -1. It'll work. But I just chose not to teach it that way.
We're just fine with the idea that the last thing's positive. Let's just do that.
I like it. And we got a little saying, right?
It's
The
not
little-
like harder than asking.
All right. Now, basically that completes all the forms of factoring that we're going to look at, right? So now we're going to start looking at uses of factoring. And I showed you one use, which is when I have a ratio of two things, and if I can factor, I can see what's common. I don't know if you guys remember that. But we're about to talk about, let me ask you a really kind of weird question. If I have one number times another number equals 0, is there something that has to be true?
One opposite sides.
No. -2 times 2 is -4, not 0. Yeah, either A is 0 or B is 0, or they're both 0, right? That's the only way that I can multiply two numbers and have them come out to be 0 is if at least one of them is 0. Is everybody cool with that? And on one level you're all like, yeah. But this is going to become huge. What if it was 8 times B equals 8? Is there anything that one of them has to be? It could be 8 and 1, 2 and 4, 16 and 1/2, 800 and 1/100th. I mean, there's an infinite number of things that they are allowed to. There's nothing that either one has to be. Only when it equals 0 does it make the fact that one of them has got to be freaking 0. Right? At least one of them. Okay, so how does that apply to anything we've been doing, right? You're like, that's a neat thing, Jeff, sir, whatever. So what if I had this then? So let me start us off nice. What if I had x times y equals 0? What are the answers to this? Either x is 0 or y is 0. So that's done. Yay. Now watch. Here's where you're really going to be. This is going to be the real problem. And it's nothing major. I want you guys to realize. What if I had x plus 5 times x minus 2 equals 0?
One of those is
Yeah, either, how many numbers do I have up here? 1, 2. So it's the same thing. Either this is 0 or this is 0. So either x is
Because x can't be two numbers.
solve. Either x is
0.
no. Okay, let me try again. If x is 0, what do I get?
5.
No, I get -10, right? If x is 0, what's the product? -10. So 0 is not an answer here. Why was it an answer here? Because there's an actual x there. Here, there's no x's. I see x plus 5. I see x minus 2. X plus 5 is 0. Is everybody cool with me writing that? Because that's saying either this number is 0 or that number is 0. Now solve this little equation we just wrote. Solve it. How do I solve it? Subtract 5. I get x equals? Oh, thank God. All right. Or over there, I get x equals 2. Some of you guys might realize, what makes this 0? 2. I don't have to write that shit. What makes this 0? -5. I don't need to write that shit. You can write this if you need to, especially if these get a little weird. You want to have an equation you can solve instead of trying to guess in your head. But when there's this, I would hope that some of you guys can just get the answers by looking at it. What makes that 0? -5. Do I care what that guy is? If this guy is 0?
No.
It don't matter. The whole thing's going to be 0. I don't care what that is. So obviously, hopefully you guys understand, the problem is going to not start out like that normally. Somebody has already done what to this problem? They've already factored it. Right? So now we're going to get this kind of problem. What you got, Jeff? I don't know. Okay, that's fine. So that's the way it would normally start off.
Do factor.
Now, I really want this to make complete sense. Why can I not solve this equation like we did before, getting x by itself? Well, when I had say again, sir? There's what?
There's an equal sign.
Okay, but if it was this, couldn't I just subtract 12 divided by negative 7 and be done with it? There's no factoring there, right? Because with a normal equation, if that was not an x squared, couldn't I just get my x's together? That's one of the steps. Get your x's together on one side, get your numbers. Can I get my x's together the way this is? No, these are not like freaking turbo shit. So that we had to develop another way to approach it. We take this ugly trinomial dude, and we break it down into two little binomial dudes. We trade off an ugly big equation for two small easy equations. That's the trade-off. How do you factor this? They have to do what? The numbers have to multiply to 12, add a negative 7, 3 and 4. And they both have to be. Yeah, they both have the same sign, so they both have to be negative, so they'll add to be negative 7.